Perhaps you find yourself in this predicament where you need to get information about your router in order to calibrate it, but the information that you need is not available. You probably bought this off of Amazon or eBay or even Facebook Marketplace, where that person definitely wouldn't know what anything is. You could try to ask the seller, but quite obviously there is a language barrier because these things generally come from China. Not saying anything bad about China, but in my own personal experience, they don't particularly care that much about the customer experience. You know, that's just the way it is. But we need to know things about the stepper motor and the lead screw, and you could try asking them. They may know, but you might not get anything back, or they just don't know in general. So, how are we going to find this information out in order to calibrate our machine and create fairly accurate parts? We don't have the information we need. We need to know about the stepper motor and the lead screw, but those aren't available. So, how do we do that? We are going to have to perform an experiment to calibrate our machine using the data that the machine will provide through its movement and how it's currently set up, and use that information to make adjustments. First thing you're going to want to do is find something that's very square, perpendicular, and parallel to the travel, and that dimension does not change, like this 1, 2, 3 block, which is very, very accurate. More accurate than anything that this thing can do anyways. So I'm going to move it along. I got my dial indicator. You can get one of these for about $30. You can see that the dial is not moving. I have this positioned just right so that it's parallel and perpendicular to the travel of this unit. Okay. Now I'm going to get that out of the way. Need to loosen this. I just have the machine turned off so I can turn these by hand. Once it's on, the stepper motors lock into place. This is just a 4 millimeter shaft, so you can need a 4 millimeter collet. They're usually 3/8 or 4 millimeter for those indicators. The next thing I want to do is lower this down so that I can measure this and try not to bump this. I only have it held with one bolt, so I got to be a little careful not to force it out of position. So I want this so I can clear it and still be able to get a caliper on it, like so. And you're not going to be able to tell because it's black and it's the only marker I could find, but I marked one side here so that I'm always measuring from that same side. There could be a little bit of run out in the motor. You always want to measure from the same degree of rotation here. All right, and make sure you lock this thing in place, this collet nut. I might have to lower it ever so slightly now that it raised up. We don't want this collet nut to be able to move. So I'm going to lower it down again. That's too close. Alrighty. Here we are in UGS. I need to connect the machine, so I'm going to go up here, make sure all your things are selected and they're correct. Let's connect the machine. Now let's go to our toolbox and unlock it. So now the machine can move. Let's go to our jog controller, and I'm going to set the step size for right now to be just 1. I'm just going to get it to move one way and then back the direction that we're eventually going to get it to travel to. And I'm going to choose a sample size of 50 millimeters. The bigger that you can go with this, the greater that the error is going to be reduced by. And what I'm going to do now is get up and measure that distance. All right, we got our caliper, our block. Make sure we have it turned to the right spot. I'm gonna reset this here. It's kind of goofy. Let's get it at 0. All right, the battery cover on this likes to move and uncharge it, I guess, however you want to think about it. So I'm going to hold this caliper directly so that's square. You can see if I hold it like that, that's no good. And get a measurement. And I have 93.55, and we're going to want to write that down. Okay, let's get this caliper on here and see how much it actually moved. Ideally, it would be 50 millimeters. But right now, I got a measurement of 42.79. All right, so let's input that into my little spreadsheet. 0.79, I believe. And that's just going to tell me the disparity. And I'm going to do that 3 times and just create an average of these 3 values here for the actual travel moved. So I have these 3 values here. I redid the first test, well, not on camera, it's a little easier. So I need to create an average. Oh, right there. So I got 50.423. And I'm just going to repeat that for the x-axis. The z-axis will be a little trickier. I'm going to have to use the caliper in a special way. But I'm going to come back once I have these values. All right, this is my solution for measuring z. I'm going to go on top here, take a measurement to the 1, 2, 3 block, stood up on this 3-inch dimension. Got 101.9. I have to be careful because this is about to hit this in about 36 millimeters. So I'm only going to be able to do a 30 millimeter move. So let's get this measurement. 101.10. In UGS, when you connect to your machine, we're going to need to pull some information that it's going to provide. When you connect it, you're going to get a bunch of weird language here with dollar signs. And on the right, it says what these things do or what they are. We're going to pay attention to 100 through 102. 100 is your X, 101 is your Y, 102 is your Z. We're going to want to record this number, and this number here. And we're going to want to write that down if you're doing this on paper. Or for me, I'm going to put it over in my spreadsheet, which I already have done. Here's 1, 2, right there, 3. Here's our formula on the right. We're going to use that information we collected. We have our old rate, which is this. Our intended travel, that's what we wanted it to be. And then we have our actual travel over here. So we have our old rate multiplied by the intended amount of travel. Do that first. And then we divide that by actual. So I'm going to do this in here. So I don't have to use a calculator. You can watch me do it too. So we have our old rate multiplied by our intended rate. I'm using parentheses because I want to do this multiplication first. Otherwise you get an answer that you don't want. And then I'll do that and I'll hit enter. We would expect an answer greater than our old rate because it was not traveling quite far enough before. Now let's do the exact same thing with our Y. Equal sign, our old rate multiplied by our intended travel divided by our actual travel, which is here. And we would expect an answer less than what was on the old rate because it was traveling too far and we need less steps. Okay. And I've already done the Z right here. Exactly the same. It was traveling too far, so the old rate is greater than the new rate, and I want the new rate to be less because it was traveling too far. You may be asking, what are we going to do with this information? How are we going to get it to our machine? We are going to go to our UGS, and I need to unlock it so I can talk to it. Make sure that it's connected. We are going to put in $100. This is for X. 100 is X. Equals, and our value over here, 804.393. I'm just going to go to 3 decimals, and that fourth digit is a 2. So 804.393. And hopefully, okay, it says okay. Let's do that for Y. So we're going to type in $, don't forget the $, 01 equals our new information. This is 588, 801.588, 801.588. Hit enter. It says okay. Let's do this for our Y. 802.780. So we're going to do $102 for Z equals 802.781. I'm going to round up that 5. 802.781. Enter. And we can see the last 3 commands. We got 100, 101, 102. That's the way it should be. All right, I've forgotten the command on how to pull up this information on the machine. So what I'm going to do is I'm just going to disconnect it and then reconnect it. Reconnect it, there we go. And all the stuff should be pulled up again. And we will verify that the information that was just retrieved from the machine is our updated values. If one's wrong, you will just have to do what we just did over again, only for the wrong ones. And with that, your machine is now ready to use, and you can verify with a caliper after you made a part to see how close you got. All right, now we can take our part that we just made in here and just see what it turned out to be. This is supposed to be 105 millimeters even. And as you can see, I got a 1/4 millimeter greater than what it should be. It's really close, over 100 millimeters. And obviously the longer the distance that it's measuring or traveling, the greater the error. But it's really close, and I don't want to go through this process again and do all the measurements. I'm just going to use this data that I just collected here, maybe just trim off that last decimal place to a greater number or a lesser number. In this case, it would be lesser. And I could do it with the other axes as well. But so far, I'm pretty happy with it. Turned out pretty good.